Next we get to the collision theory, which is a very important theory used to explain why the reaction rate is what it is, and there is a reference to a YouTube video that you may go to. So what is the collision theory? What is it about? Basically, it says if there isn't an effective collision between particles, then there will be no chemical reaction. So what could determine the effectiveness of a collision? It says a reaction will only take place if the particles collide against each other with sufficient energy and the correct orientation to cause a rearrangement of atoms, and a rearrangement of atoms just means that there is a chemical reaction. Old bonds are broken, new bonds are formed. So particles must collide. They can't react if they don't collide. They must have sufficient energy. So if they do not have energy greater than the activation energy, then the reaction can't take place. And then they must have the correct orientation. So let's look at particles and their orientation. Here we have an ethene molecule with its double bond between the carbons and each carbon attached to two hydrogen atoms. Here we have hydrogen chloride, but the hydrogen chloride, the chlorine part of the molecule, is attacking or moving towards the hydrogen part, a hydrogen atom on the ethene molecule. And here we have hydrogen chloride, where the hydrogen part of the molecule is going to collide with another hydrogen on the ethene molecule. So this demonstrates the orientation of the molecules, where the chlorine or the hydrogen of hydrogen chloride attacks hydrogen atoms on the ethene. Now ethene is reactive. The double bond is the reactive part of the molecule. If the hydrogen chloride attacks the double bond, then the double bond will break, forming a single bond, and you can have an addition reaction there. So this is an example describing the effect of the orientation of the atoms or the molecules in a reaction mixture. Only if the double bond is attacked will it be able to break to form a single bond and have addition reaction here. Next, I have to explain the factors affecting reaction rates using the collision theory. So the factors were the concentration of the reagents, the temperature of the reagents, the surface area of the reagents, and then also the use of a catalyst and the type of reagents. Type of reagents we're not discussing here. It is about the temperature, the concentration or pressure, the surface area, and the catalyst. So first of all, the reaction surface. We've already discussed it, that the reaction rate between a solid and a liquid or a gas increase with an increase in reaction surface. Now, to explain this, an increase in reaction surface leads to a greater chance of collisions taking place, resulting in more effective collisions per unit time. So this is using the collision theory to explain why the reaction surface affects the rate of the reaction. Secondly, the concentration of the reactants affects the rate of the reaction. Now, the higher the concentration of the reaction, the more particles of the substance will be present in the reaction chamber, so the reaction will occur at a higher rate. So the explanation using the collision theory is the higher the concentration, the more particles are present, leading to a higher number of collisions per unit time, resulting in a greater chance of effective collisions taking place.